All right, let's work these last examples here. Taking a look at example 4. We're given that AB, which is the entire length of this secant, is 14. And we're given that BR is 5, so we know that AR must be 9. They gave us that TC is 5, and we don't know what TA is, so why don't we go ahead and give that a variable x. And we're asked to solve for TA as well as AC, so it makes sense once we get TA we should have AC. So let's go ahead and use our secant formula that we just talked about in the last video. So taking a look at the secant we know everything about, AB, we know that the exterior length of 9 times the entire length of 14, so that's the exterior times the total, should equal the exterior segment, AT, times the entire length, x plus 5. So we can multiply this together. 9 times 14 is 90 and 36, 126, equals x squared plus 5x. Subtract the 126 off. And we're looking for two numbers that multiply to negative 126 but add up to 5. So we need a positive and a negative. So how about, let's see, the numbers we started with, 9 and 14. We'd want the 14 to be positive, so this will factor to be x plus 14 times x minus 9. We would get two solutions, x equals negative 14 and x equals 9. Now, only one of these really makes sense here. Since we can have a side length of negative 14, x must be 9. So if x is 9, that would lead us to believe that TA is 9. Therefore, AC, the entire length, in this case, also worked out to be 14. All right, next example. They gave us that SV is 3, VR was 9, and we want to know what ST is, this tangent, so we'll call that x. Using the tangent rule, we know the tangent squared is equal to the outer part of the secant times the whole secant. So x squared is 36. X would equal positive or negative 6, but since we're talking about side length here, x should only be positive to ensure we get a positive side length. So if x is 6, that would tell us that ST is equal to 6.